Three dice, each of which has its 6 sides numbered 1 through 6 are tossed. The sum of the three numbers that are facing up is 12. Is at least one of these numbers 5? So the first thing that we have to do here is make the central spaces in which the sum of the three dice is 12. So let's make a case. Let's assume that the one die shows 1. That means sum of the remaining die is equal to 11, which is possible when one of them is 5, the other one of them is 6. Now, the second possibility is that if one of the die is 2 instead of 1, then the sum of the remaining two die should be 10. And the 10 is a possibility when one of the die is either 4, 6 or 5, 5. So, I'm not counting the arrangements, I'm only making the identical cases here. We will consider the arrangements later. Now, if one die shows 3, then the other two dice will have to show some 9. Some 9 can have various possibilities. For example, we can start with 3, 6. The other possibility is 4, 5. Then we have 5, 4, 6, 3. That means once again the repetition of them. So these are the cases. If one of the die shows 4, then sum of the remaining two die should be equal to the remaining 12 minus 4, that is 8. For 8, we can make the cases such as 2, 6, 3, 5, and 4, 4. So all these cases considering one of the die as 4. We also have to ensure that there should not be any repetition. So 4, 3, 5, no such repetition as such. Now, if the first die shows 5, then sum of the remaining two dice should be 7. And we already have taken 1, 6 with 1, 5. The 7 can be 2, 5. That's also taken. The sum with 1, 5 can be taken 3, 4. And then 4, 3, etc. That means all other cases we already have considered. Now the cases have started repeating, which means we can remove now this case. Let's understand, because all three numbers are different, so there are 3 factorial arrangements. The same here, 3 factorial, but here the arrangements will be 3 factorial over 2 factorial because we have these 2, 5 identical. That means while we have 6 arrangements of the first two cases, the third case will have only 3 arrangements. The same will be true for the fourth case, 3 factorial over 2 factorial, that means 3. For this particular case, 3 factorial, that means 6 arrangement, all 3 identical. So 3 factorial, all 3, 4, 3, 5 are identical. Okay, 4, 3, 5 we already have considered here. So this case does not need to be taken into account now. And this has only one arrangement. So the total arrangements that we have is 6 plus 6 plus 6 plus 6 plus 6. That means 31. And the total outcomes of the 3 dice can be represented as 6 into 6 into 6. That is 216. However, we only need to understand that out of these 31 cases, the cases in which the number 5 appears are the cases which are these 6, then these 3, then these 6. That's all. That means the favorable cases are 6, 3, 6. That means 15 cases are the favorable in which one of the numbers shows 5. Now we have to find out whether one of the numbers is 5 or not. The first statement, none of these 3 numbers facing up is divisible by 3. So no, none of the 3 numbers is divisible by 3. That means we have to see what all cases are showing sum 12 in which none of the numbers is divisible by 3. This is one case, and this is another case. So while in one case there is 5, in the other case there is no 5. Therefore, we say that the first statement alone is not sufficient because 5 may or may not be there. Now let's look at the second statement. The second statement says that of the numbers that are facing up, 2, but not all 3 are equal. That means this 4, 4, 4 is out. We have all other numbers left. Now in that case, we can have one possible combination 1, 5, 6. We have another possible combination 2, 4, 6. While this combination gives us answer to the question as yes, this combination says no because none of them is 5. And therefore, second statement alone as well is not sufficient. Now we move to the third step. That means combination of the two steps. In the first statement, we had only these two possible outcomes in which none of the three numbers had any multiple of 3. And out of these two cases, the second statement compels us to drop this particular case because the second statement says that all three are not equal. So the only case that we are left with is 255, which means the answer is yes, because this case includes 5, and therefore we say that the statements together are sufficient to answer the question, and hence the answer becomes option C. Thank you so much.